Okay, in this problem, we have a house that's valued at $116,000 in 1985. Then by the year 2005, the value had appreciated exponentially to $140,000. So what was the annual growth rate between 1985 and 2005? All right, so in this problem, we can assume that the value of the house is growing continuously over time. So in other words, every day it's worth just a little bit more. So we can use the model A of t or y, whatever you want to call it, equals the initial value times e to the rt, where a is the initial value and r is the rate of growth. Now that's what we're trying to find. It says what was the annual rate of growth. So that's actually what we want, is we want r as a percentage. All right, the initial value, that's this coefficient little a, which is when t is 0. So I'm going to let 1985 correspond to t is 0. Then in 2005, that's 20 years later, so that's when t is 20 in 2005. Okay, so the initial value then for little a would be 116,000 times e to the rt. And now the only way to find r then is to substitute in a second point, and that's where this comes in handy, knowing that in 2005 the value was 140,000. So we can plug that in to solve for r. And we'll put in 20 for t when the value is 140,000, and we're going to solve this. Now we're rounding to 2 decimals, so I'm going to go ahead and open up the calculator here, which we are definitely going to need. Now when I divide both sides by 116,000 to get that out of the way, at least 3 of the zeros cancel, so I'm just going to write it as 140 over 116, which, yes, further reduces, but for now that's fine, equals e to the 20r. Okay, we want to solve this for r. So in order to get that variable out of the exponent, we've got to take the natural log of both sides. And I'm using natural log because we have e's involved in the problem. And so that will just simplify it a little bit. So the natural log of e to the 20r reduces to 20r. So then the rate r is equal to the natural log of 140 over 116, all divided by 20, which we are going to have to round. It says to 2 decimal places after we make it a percentage. So we'll do 140 divided by 116. We'll take the natural log of that number and then divide that by 20. So as a decimal, we have 0.00940. Now when we move that over to make it a percentage, we get 0.940%, and since we're just rounding to 2 decimals, I can just leave it at that. So this answer would be 0.94. Then, part 2, assume that the value continued to grow by the same percentage. So in other words, r stays at 0.94%. That's how much the value is going up per year. Then it says, what was the value of the house in the year 2010? So that would be when t is 25. Well, we can plug r into the model right here. So we get a of t is equal to 116,000 times e to the r. We use the decimal version in this, so 0.0094 t. T is 25. Now, in order for the computer to accept your answer, I believe we're probably going to use this rounded value of r. If it counts that wrong, I would reuse this calculator version for r, which is more precise instead. But I'm going to try the rounded version first. We might get an answer that's just slightly off. We will see. Okay, so, well, actually, we can just go ahead and type that into the calculator as it is. Actually, I take that back. I'm going to use the long version first since I already have it in my calculator. So I'm going to multiply this r times 25. Okay, and then I want to raise that as an exponent on the e, so e to that power is 1.26, and then times 116,000 gives me, okay, with the unrounded rate of growth, I get 146, and this is round to the nearest dollar, so 146,739. Now if we round for R, let's see if we get something different. So if I round for R, we'll have 0.94 times 25, and that's going to be an exponent on the E, times 116,000 comes to, oops, that didn't work. Oh, I think I forgot my 0.00, so 0.0094 times 25, I should have noticed that, it's 0.235. That goes on the exponent as the E, there we go. Then times 116,000 comes to, yeah, it's a little bit different. It's about $10 off actually. So 146,729 if we use the rounded version. And I did double check, the computer's actually wanting the unrounded version, so they want that answer right there using the more precise value of R.